before removing that electron. But it's always the last electron. It's all we're focusing on. So the last electron. So if I repeat it all, Christian, that was great. This electron's easier to remove because it's in an additional sublevel that is further from the nucleus with an additional sublevel below it causing shielding effect, or it has more shielding between itself and the nucleus compared to BE. You could say it that way. It has additional shielding due to having the 1s and the 2s versus just the 1s. Okay, so this is a great example of just looking. It's not about, oh, it has that 1 and it doesn't want to have the orbital filled with only 1. It wants to be full. No, it's more about the idea of distance and how strongly that electron is being held from the nucleus. Can I talk about nuclear charge again? Can I talk about nuclear charge? Nuclear charge would be a really bad decision on this one. Okay, so this is about shielding and about adding sublevels. So why I brought this one up and why I really hustle, I remember this is the one when the class was ending. We don't think about this as being like an extra level. Every sublevel adds a little distance. Every sublevel has a little bit more shielding. It's not always just about the energy levels. Rory.
You go like 1s and then 2s and then 2s or 2p, and then do you go like down, like beginning 1 and then like 2, or do you go 1, 2?
It doesn't matter which way you go. I guess when we write them on a sheet, we write downward because we don't know when we're going to run out of space. But for visualizations, usually we think of like a nucleus here and we move up. It doesn't matter. Nucleus is here, you can do 1s, 2s, great. Nucleus is here, 1s, 2s. Either way, okay? All right. Now we're going to get into a couple situations that we probably haven't talked about before. So this will be really good to talk about. Is this on your sheet, I think? Yeah. All right, and I missed one, I believe. But anyway, Zn and Ga. So here's Zn, here's Ga. Okay, zinc and gallium. Your job is not to tell me, or to know that zinc is more difficult to remove. Your job is to just quickly, or not quickly, your job is to be able to convince me why it's much easier to remove the electron from Ga than from Zn. And I'm going to only give you about a minute and a half on this one. Because just talk with your group, because it's, some of these start to link now. We've done 2 already, there's certain similarities. I'm going to add an element. Let me add a wrinkle just in your explanation. Why is this such a larger drop than the one we just did? Look how much more of a drop. It looks like it's much easier than the previous one. I want to bring that up. Bless you. Just as a potential thought, if you haven't been processing that. So if you haven't seen what I put on, I do have something up here. If that helps with your conversation. And it's linked to the proper one. You won't have to necessarily. What do you mean?
Like, are you going to give us, like, oh, do zinc?
I wouldn't give you this. No. And that's why the packet was so important for us, and we're going to continue to practice it. Give you about a minute more. So definition of what? Is how many protons. So if you have like 4 protons versus 6 protons, you could say the nuclear charge of carbon is 6. That's just it's a fancy way of saying it. No, the bigger the number, the stronger the nuclear charge. Just the more protons, the more. It's the atomic number, yeah. Yeah. All right, a different group. Please explain this to me. Someone else that hasn't spoken. Assume maybe every group's going to have to speak eventually, so if you think you got it down. Someone from a group, volunteer. Else I will pick the person who's trying not to look at me. All right.
GA is easier to remove. as it has a lone electron on an additional sublevel, which means that that electron is further away, which means that it's easier to remove.
Okay. Any other, and I'll open this up to anybody. This was not part of the initial question. Why is this one so much easier to remove than the previous element versus B versus BE? Dane.
It's even farther away than B.
Perfect. It's even farther away, and one other thing. Even farther away, and Kyler? It's a whole new level, but there's something else.
Is it that Zn is completing the third energy level?
Not necessarily. Something not as complicated. Shielding, like increased shielding. Look, we've added 10 extra electrons in here versus the previous one. What did we add? We had 2 electrons blocking it, right? So, and we got to be very careful about talking about, and I get where this goes, and you probably were taught some things like this, like, oh, a sublevel's full. It doesn't want to remove it. Like, anytime you think about it that way, it's almost impossible not to talk about this without saying the word want then. If you're like, well, it's full, so shoot, I don't know how to end it now, because you get stuck. So it's always about distance, it's about shielding, it's about attractive force. Yep, so if you just imagine my nucleus down here, okay, it's trying to attract that last electron. It's trying to attract that last electron. So all this other stuff, 1s, 2s, all of it's in the way. And it's diminishing or weakening that attractive force to getting that, holding on to that electron. So if I have all this in the way, like this one, if my nucleus is right here, and I'm trying to grab that electron, basically none of these are blocking that attractive force because they're all the same distance, okay? But this one, all of these electrons are additionally weakening my nucleus to the outer electron and that force between the two. So this is an amazingly increased amount of shielding that has occurred in this atom versus that one to remove that electron versus that one, okay? So every time we add a sublevel, we're adding shielding, which weakens, which causes the atom to get bigger, which causes that electron to be more easily removed. Okay, so that's what it's very similar to the last one. The difference is it's much more shielding, and I wanted you to see how that D worked versus that other one. All right, we've got 2 more. What about that one? Ne versus AR. So explain to me why Ne, it's more difficult to remove an electron from Ne than it is from AR. And this is all priming us for our free response. So that's why we're just kind of flying through these. Is that one of the other options? Okay. No, that's... Okay, and I apologize, that is not on your sheet, but you can kind of do it maybe on the side eventually, because we have 5 of them. I only did 4. So understand that one's not on there. Well, it's right here. So, well, NE's stronger, it's higher up than AR. So this one's not on your note sheet, but you can write it on the side somewhere. Okay, if you want to wait for the explanation, great. I see a lot of people already writing, which is fantastic, but it's your call. All right. Group, tell me, explain it to me. This one we don't need to discuss long. New group, someone. Someone here?
You add more sublevels.
Greater, yep. And we always want to, it's good. Always want to make sure that we refer to where that last electron is versus the nucleus in this situation. So with argon, the electron is further away, right? And I would make sure I would say energy levels. I've increased energy levels, which has increased shielding, and is causing my electron to be further away and not held as tightly in the argon versus the neon. That's it. That's all you would need, okay? You could miss maybe one of those parts and still get it. Again, nuclear charge doesn't work. I'm trying to emphasize for this first part of class today that it's not always about nuclear charge, because everybody always wants to talk about nuclear charge once we start talking about it. So you can write that on the side somewhere. That was the one that I don't have on the back. I apologize. So again, I'm showing you 5 situations that are probably going to come up in some way on your test. So it's extremely helpful for you to refer to these. So here's our last one. Oh, sorry. So I did have images, so you can just see Like there are my 10 electrons versus my 18. Don't worry that they're X's. Just that last electron is further away than the neon, and there's more energy levels, which causes more shielding. Okay? Rory.
Do we need to know how to draw those things? I kind of forgot.
Well, I mean, it all you should be able, it's 1s2, 2s2, 2p6, so this is the 1s2, 2s2, 2p6. Like, it's not specifically any one place. Okay, and that's what the packet's all for, too. It's trying to get us back in electron configurations. Last one. Whoa. Why is argon and potassium so different? Why is it easier to remove an electron from potassium than it is from argon? And again, I'll give you one more minute, and then we're going to get into I think, the more difficult part, which this will all have helped you, and you're going to actually want to write for this one.
It's because there's more energy levels what they are, which increases the shielding effect.
Yeah, which I would say causes the electron from argon to not be held on as tightly, or not be held as tightly. Something along those lines. What's the simple truth on this? It's not about full octets. It's not about noble gases. This is the electron we're talking about versus one of these. Why is that one so easy to remove? And it's clearly much easier to remove. Why is that one so much easier to remove? We've already stated it in many different ways already. Kyler? Yes, and we have to say one thing that is the biggest difference between the two. No? No, because this has a greater nuclear charge, which means it should be holding it tighter, and it's not. Radius, it's larger. Why is it bigger? What's the biggest difference just by looking at this? I've gained an energy level. I've gained an energy level. Right? I've gained one energy level, which has, you're right, Kyler, has increased the shielding effect, but the electrons are further away. If you're ever having a hard time talking about this, you can say that the electron is not being held as tightly or as strongly. You can say it like that. Like, think about the nucleus literally holding on to that electron, and it's either tight or loosely in its grip. Okay? So, that being said, on the other side are AP questions, actual AP questions. So what I'd like to have happen is I like this side, right? Actually, this group you do A, okay? You do B, C, D, A, B, C, D, A, B, C, D, okay? I want a written out answer of this. So explain each of the following observations using principles of atomic structure and or bonding. Group A, potassium has a lower first ionization energy than lithium. Group B, the ionic radius of N3- is larger than that of O2-. Group C, a calcium atom is larger than a zinc atom. And Group D, boron has a lower first ionization energy than beryllium. Group D, you have benefited. We just did this one, but I want it in a perfectly worded problem. So you're going to write it out. Someone's presenting. Of the three different groups, someone's got to present. So I'm going to call on somebody. Be ready. Everything else, erase it, and you're writing one. Yeah, you're writing it. Who else was supposed to be in your group, you two? Katie. I knew I was missing one person. I couldn't figure it out. All the answers will be posted eventually, so I wouldn't worry about writing them out on your sheet unless you want to. Try to get them on the board first, please.
So the calcium atom is going to be larger than 60.
Are you talking about energy level? Are you talking about shielding? Are you talking about nuclear charge? Some of these now are about nuclear charge. When do you bring up what topic? Yes, I want the answer on the board. You don't. I might pick you. If I don't pick you, I don't pick you. Guys, you have a 33% chance of being chosen. You need to have it on the board. Even though I guess it's going to be hard to present it, but I just want the act of writing. It helps. It really does. Can letter D, you guys got kind of not a softball, but you definitely have had this question already today, so, but make sure you're wording it right, letter D. Because.
Well, because. I missed my
Can give you about another minute and a half. So if you haven't sensed this yet, there's going to be quite a large spot on the test where you have to explain multiple different phenomena on different situations of size or ionization energy or relationships of the electrons to the nucleus. I'm kind of available all day because I'm not teaching. So you can always stop in, and if you need any questions, I'm going to be sitting in the back. Mr. Neubauer's teaching today. Yeah.
Single electrons increasing distance
All right, we're going to get in. So letter A, I'm going to spin the pen and see what it points to. That pointed to no one. Who has an A over here? Is there an A over here? Yeah. You're the A? Okay. What do you got? I envision I brought a tripod that everyone would walk up and everything, and we don't need to do that. So please listen and learn, and then we'll see what I have written as well. See if you match what I have.
Potassium has more energy levels and also a greater shielding effect than lithium, so its ionization energy is lower. The increase in energy levels causes a further distance between its outer electron and the nucleus, causing less attraction. And we began drawing a picture.
That's fine. Terrific. So now this is now this is all on your back of your sheet. So if you want to write these out, this is extremely specific. And that was great. Good job. Potassium's valence electrons, you don't necessarily need to write exactly what they are, 4s, while 2s, but it is important to recognize that you should touch on both. You should touch on both. So potassium has 4s1 while lithium has 2s1. Potassium's electron is shielded by more electrons than lithium and is therefore more easily removed at a lower energy. So I feel like that's basically what you guys said. Very good. So that one, and we've already ran into a couple other ones like that, we are moving down a group, right? Same group. So then what we discuss is the shielding and the fact that the electron is further away, which is easier to remove. Done. Succinct and is right to the point. But state what my suggestion for all these, and I should have said this in the beginning, I like to state what both, what's going on with both. Like this has this for an energy level versus this, or this has this for a nuclear charge versus this, and then explain why. Okay? So that is for letter A. Let's see who the lucky group is for B. Oops. I'm going to say either side points. Are you a B? You're a B. All right. The ionic radius of N3 minus is larger than that of O2 minus. Group B, what do you think and why?
Well, I don't get this. Okay. N3 minus has a larger radius, or atomic radius, ionic radius of O2 minus because the nuclear charge in nitrogen is lower than nuclear smell?
You were there. You were right. All right. You hit they hit what they were supposed to, and then they started to contradict themselves. If it's larger, that means that it can't be pulling in the atoms electrons as closely, right? This is way too long. This is what I'd say. And it says about isoelectronic, I would state, although they both have the same number of electrons, you got to realize that, so it has nothing to do with electrons now. O2 has a greater nuclear charge, or they stated N has a lower nuclear charge, which causes the electron, the electrons aren't pulled in as tightly. Okay, it depends on the frame of reference of which one you're talking about here. O2 has a greater nuclear charge, so it's going to be pulling the electron cloud closer, and the electrons are going to be held more tightly. Nuclear charge is protons. If you want to say protons, that's fine, but the money word really or phrase is nuclear charge. If you phrase it nuclear charge, that has a bigger and bolder statement. Okay?
You just go both.
You can, then you're just saying like PLT time. That's what you're saying. Or ATM machine.
What is it? Automatic.
Teller machine. So if you say ATM machine, you're saying automated teller machine. Right? So, we clear though why? When I'm on the same row, this is get this out of the situation. If I'm on the same period, a row, it's probably about nuclear charge. When I'm on a column, it's about distance and shielding. Okay, terrific. Again, that is crazy in depth. Is there a C? All right. I'm going to move on. Sorry, you can get this from me later if you like, but I've already stated it that O2 has a greater nuclear charge, which causes the atoms to be pulled in tighter. Okay. Calcium atom is larger than the zinc atom. Gentlemen?
As you go down the columns, the shielding effect increases, and as you go right across in the rows, the radius decreases. So the nuclear charge goes up as you go to the right. Thus, Cn can hold the electrons tighter, making Ca the larger atom.
Terrific. A couple things. First, be careful when you're saying right and down, because this is a table, but we're talking about two atoms. So be very, very careful about saying directions and things. You want to be very careful on how much you say directions and things. But very good. That's the even though zinc atom contains more electrons, and you don't have to say that necessarily, the big thing is, it has 10 more protons, the nuclear charge pulls the electrons in more tightly, reducing the size. That's a great last phrase. The nuclear charge pulls the electrons in more tightly and reducing its size. I'm trying to give you ability to phrase your ideas in as a short and succinct fashion as you can. There's a lot of other stuff here that wouldn't be needed, but you should talk about each again. So, you know, if you feel like, well, yeah, there's more electrons in this one, it's not about the electrons in this at all. It's about the nuclear charge, okay? And then group D, I know we already had this, but I would love to hear it again. We're going to go over here. Where's a D over here somewhere? All right, why don't you give me D. Boron has a lower first ionization energy than beryllium.
Boron has a lower ionization energy because there's an extra sublevel of electron and 2p. And the shielding effect is stronger due to the extra sublevel.
Okay. Did you say that was further away? It's okay if you. I'm just curious. I didn't feel like. All right, that's fine. So great job though. Receives the benefit of the shielding effect, and I know it doesn't say it on here, but it would also. I do want us to recognize that every time it's in a new sublevel, it is a little bit further. That is a big deal, even if it doesn't say it on that example. So it receives the benefit of shielding effect. We are going to quick go over those other ones. We got 3 minutes. Come on. All right, on Thursday we'll talk about those other 3 problems. Save the sheet. That's great. Have a great day. Atomic structure 2 due today if you haven't already handed it in.
For B, could you just say, since it's moving, or since it's like, for B, you want to say atomic radius would increase?
I don't think that I have that.
But it doesn't. It decreases as you go across normally, because the nuclear charge is bringing it in more. As you move across, it gets smaller.
Well, it goes from N, it was N.
Which one is that? Letter B or B? Oh, yeah, the nuclear charge.
And it was N like minus versus
Yep.
O2 minus. So wouldn't it be like reverse of the previous one?
It is, but they both lost electrons, so they're both kind of sitting on neon. So, like, you need to talk more about that.
Yeah. Jeez.